All right, so for the last topic of Unit 1, we are going to talk about how we identify types of numbers. So I like to start off with the analogy of animals. So animals are sorted based off their characteristics, and they're sorted into two major groups, vertebrates and invertebrates. Vertebrates have a spinal cord, whereas invertebrates do not. And so we can take any animal and based off of its characteristics, sort it into a category. So for instance, a bear. A bear is an animal, so it would start up at the top. It has a spinal cord, so it would be considered a vertebrate. It's a warm-blooded animal, so it would be considered warm-blooded, and it has fur, so that makes it a mammal. And so just like we classify a bear by its characteristics, we're going to do that with numbers. So we're going to come back to this chart at the end. You don't need to copy it down just yet, but basically we're going to be taking all numbers, which are called real numbers, and we are going to be sorting them based off their characteristics into either the irrational or the rational column, just like we categorized animals as either vertebrates or invertebrates. So it's important to distinguish the difference between real and imaginary numbers. We are going to be dealing only with real numbers this year. In high school, you learn all about imaginary numbers, but just so you know, an imaginary number is when you square root a negative number. It's impossible. It's impossible to do this with the numbers that we know because what number times itself would be considered negative 16? 4 times 4 would be positive 16. Negative 4 times negative 4 is positive 16. So there's no number that multiplies to be negative 16. Therefore, it's imaginary. And in high school, you will learn that it's called 4i. 4 because the square root of 16 is 4. I because that's what mathematicians defined as the square root of a negative number. So real numbers are all numbers that are not imaginary. And can be plotted on the number line. So if we can put a dot on the number line, our number line that we know that starts, right in the middle at 0 and can go all the way up to positive infinity and go down to negative infinity. If a number can be plotted on this number line, then it would be considered a real number. And so that brings us to rational versus irrational numbers. All real numbers are going to be either rational or irrational. So rational numbers are numbers that can be written as a fraction. Because if you think about it, the root word of rational is ratio, and that's just another word for fraction. So for example, whole numbers are rational. For example, the number 4 is rational because that can be written as a fraction. It can be written as 4 over 1. Terminating decimals, which are decimals that stop, for example, 0.6, those are rational because they can be written as a fraction. 0.6 is 6/10 or could be simplified to 3/5, so that can be written as a fraction. And then the last type are repeating decimals. Those are decimals that go on forever in a repeating pattern. So the most famous one is 0.33333, 0.3 repeating, which we know is the fraction 1/3. All repeating decimals can be written as a fraction, which makes them rational. And so irrational, the prefix ir means not, like irregular would mean not regular. These are numbers that cannot be written as a fraction. And these are going to be any non-terminating, so they don't end, non-repeating decimals. So the most famous example is pi, because we all know that it's 3.1415, and then it just keeps going on from there. There's no pattern to pi. It just goes on forever in a non-terminating, non-repeating fashion. Another famous one is the square root of 2. This is 1.41, and then there's a bunch of other numbers after that because there's no number that multiplies by itself to equal 2. So this number just kind of goes on forever. If you were to type it in your calculator, you would see this huge long decimal. So any square root of a non-perfect square, so 2 is a famous one, but any non-perfect square is going to give us a irrational number. It should be noted that a number like the square root of 100 would be considered rational because the square root of 100 is just 10. So if you know the square root, it's going to be rational. If you don't know the square root, if it's not a perfect square, it's going to be irrational. So let's just decide for these ones if they're considered terminating, repeating, or non-terminating, non-repeating. So since 6.758 stops, it's considered terminating. Since 3.53535353 ... could be written as 3.53 repeating. This is a repeating decimal. 1.2 is terminating. 6.872371 ... The ... dots means it goes on forever. So this would be a non-terminating, non-repeating decimal because there's no pattern and it goes on forever. Same thing with 1.123456 ... But this one has no ... so it would be considered terminating. And as we know, terminating numbers are rational, repeating numbers are rational. So these first three are rational. These last or next two are going to be irrational because non-terminating, non-repeating numbers are irrational. But this last one, since it's terminating, is rational. So anything with pi is irrational. Any number that repeats is rational. Any square root of a non-perfect square is irrational. 0.5 terminates. This is an easy one. We know this is 1/2, so this is rational. This number goes on forever, so it's irrational. Square root of 100, though, we know it's 10. That could be written as a fraction, and so that's rational. So a couple special types of rational numbers. So all of these are going to be considered rational. Are natural numbers, whole numbers, and integers. Natural numbers are also called counting numbers because you can count them on your fingers. So those are the numbers that start at 1 and go up from there. 1, 2, 3, 4, 5, 6. They don't have any decimals or fractions. Whole numbers start at 0. So 0, 1, 2, 3, so on and so forth. So these two are basically the same, except natural doesn't include 0. Integers are positive and negative whole numbers. So -3, -2, -1, 0, 1, 2, 3 in both directions towards negative infinity and positive infinity. And then none of these have fractions or decimals included in them. That's what kind of makes them unique. So if we look at our chart, the real number system can be broken up into either irrational or rational. Then From rational, just like with the bear, we got more specific. We called him a warm-blooded mammal. Rational can get more specific. So you can have integers, whole numbers, natural numbers.